Okay, to build a FTIR table, it's a frustrated total internal reflection. Some of the benefits are an enclosed box is not required. Your blobs have strong contrast. You can also set it up to have a varying blob pressure, and with a compliant surface, it can be used with something as small as a pen tip. A couple disadvantages: it needs to have a compliant surface, which is a silicone layer. You cannot recognize fiducial markers, and you can't use a glass or hard acrylic surface. So the surface is typically a thin piece of material. Here we have a piece of vinyl. It's white. You typically want to use something that's grayish so you get better colors. On the other side, I've done the Tinkerman method, which is basically, you can see it there, it is a layering of silicone on it. So you can see that this material would never be, you don't attach it or anything. You basically take this piece of material, put it onto a surface, and use the Tinkerman method and roll your mixture of Zyol and silicone, and then let it dry. This is 4 layers, so I don't know how thick that is, but it's pretty good at making a multi-touch surface. The setup here, an FTIR surface is composed of a few things. You have LEDs going around the edge. Here I've used the 8mm LEDs from Environmental Lights. And you can also make your own LED frame out of the Osram's 880 nanometers that are also really popular, or you can just use the ribbon, which takes all of a few minutes to put around. This is a piece of acrylic in a aluminum L frame and the ribbon going around. So this is your connection to the 60-watt adapter, and this is basically its frame on itself. So we're going to put this onto the box. Okay, so we put the frame onto the table here. Basically, again, you can see the silicone layer is down. Layers are acrylic, silicone, and then the vinyl or drafting paper, whatever rear projection material you're going to be using. The LEDs are again around all 4 sides. The 60-watt adapter is plugged in. We got the projector on, the computer on, the camera is also looking at the screen. So here's the screen. When you can tell, I'm barely touching it, but I'm getting no blobs. If you push down, perfect blobs. Dragging around really fast. Camera's running at 61 frames per second right now at 320 by 240 resolution. Lots and lots of blobs. So that's basically an FTIR system. Once again, Tinkerman method, roll it on the silicone onto this material. When you touch down, the silicone connects with the acrylic and creates a better connection than your finger can. The projection material here gives the image something to stop on, and so we can run some apps. Let me show you that with the FTIR system. Okay, so this is FTIR system, and this is the Fire app. You get no tracking just by not touching the surface. I'm barely touching the surface right now, and you can see there's no blobs. Push down a little bit and you start seeing blobs. One of the good highlights of the FTIR system is using an application that is really sensitive if you have fingers that are barely hovering over, like the diffused illumination surfaces like DSI or rear DI, or even LED LP and LP. Basically all the other systems but FTIR have a problem sometimes with detecting false blobs, but FTIR is perfect. You have perfect control over where you want to control. This is a Community Earth demo. Pinch to zoom, pretty simple, and 3 fingers tilts the, so I can do that with one hand here, here we go. 3 fingers tilts the world here. There we go.